So the agenda today, first thing we want to cover is talk a little bit about the metal 3D printing industry as it is today, and then go into who Desktop Metal is as a company and the technology that they're bringing to market, and really talk about the two systems that they've been able to develop in the process and how they've been able to really revolutionize the way metal 3D printing is going to happen throughout the future. And then we'll open it up to some questions and answers, and we'll get everyone on their way to the rest of the lunch. So today's metal 3D printers are very similar to the 1970s punch card computers. They're very expensive pieces of equipment that require very specialized facilities and really specialized users, which puts a large limitation on smaller or medium-sized corporations being able to have not only the capital to purchase the equipment, to run the equipment, but also the experience to have good results with running this equipment. So Desktop Metal was a company that was really started that wanted to take on these challenges to be able to offer something to the manufacturing world that wasn't available currently today. So when they looked at, the really main challenges facing the metal 3D printing world, it was kind of broken down into 4 different areas. The first is being the high cost of acquisition or ownership. If you're not aware of metal 3D printing, the current systems, which are primarily based off of direct metal laser sintering process, are very expensive, really starting out in the $600,000 range with many third-party pieces of equipment that easily gets a customer up into the $1 million price point when all said and done. Not only is it a high cost of acquisition, the powders that are used in the metal sintering process are very specialized, so they do have a high cost of running these systems as well, which really in the end has a limitation to allowing access for other companies to be able to start running this type of equipment. The next area is long and in-depth learning curve. Once you get the equity to be able to purchase one of these systems, it takes a novice user quite a long time to become proficient in running this type of piece of equipment. From our conversations that we've had with users out there, it's up to 1 year for a new user to become a well-experienced person to be able to properly run a DMLS system, getting consistently solid, good parts off that machine. So something for a corporation thinking about buying a metal machine is, once you acquire that machine, having a user up and running is going to take you quite a long time before you're maybe seeing the results that you expected to see. The next area is specialized environments. These powder-based systems need to be in very specialized environments with ventilation and actually explosion-proof rooms. As we can imagine, powdered metal is actually very combustible. So there are safety precautions that need to be had when you're dealing with these types of metal powders and these types of systems. And really overall, the systems aren't designed for prototyping. So, with the high cost of running one of these systems and the in-depth work it takes to finishing a part, they're really not designed for a company out there looking to do, 1 or 2 metal prototyping parts. They're really meant for customers who may be looking to get into production, but when we look at production, the cost of running these systems doesn't make it sometimes affordable to be able to do larger production runs that some companies are hoping to do with 3D printing. So when Desktop Metal looked at this, they really feel that metal 3D printing has barely scratched the surface into manufacturing. And again, looking at the systems that are currently out there, they're too industrial and expensive for the prototyping needs of a lot of companies out there. So they're going to relying to either using plastic prototypes or doing their traditional CNC machining of metal parts. And the current systems aren't fast enough or have a low enough cost to really be considered a good option for larger production runs. So to give everyone a little bit of a background on Desktop Metal, if you're not familiar with them, they are based out of Boston, Massachusetts. They were founded in 2015, and really they were founded by the leaders of the company because they wanted to make metal 3D printing more accessible for manufacturers out there. They felt there was a big need in the 3D printing market to have a system and a technology that was going to be more accessible than to just large corporations who have the dollars and the manpower to be able to run some of the larger metal systems that are out there today. So since 2015, they've actually had over $100 million in investment to bring additive manufacturing metal into the mass market. You can see that they've had quite a few large name investors from Google to GE. And one of the other investors that's not listed on here is our other partner in 3D printing, which is Stratasys. Stratasys was one of the original investors in Desktop Metal, and the founder and CIO of Stratasys, Scott Crump, is actually heavily involved in working with Desktop Metal on their development. So as you can see, as a company, Desktop Metal actually has over 100 engineers right now, 14 PhDs, including 4 MIT professors. If you get on their website and you look at their founding partners, you would think it would be a requirement that you had to start and get an education at MIT to be part of that team. Some very talented professors and talented people that they have working running this new startup. And they have over 138 patents in process. So over the last couple of years, they've been working tirelessly to develop a new technology that was going to really change the game on when it comes to metal 3D printing. And their overall goal is, again, is to be able to provide companies with a true resource and a machine that they can use for their prototyping needs when they're looking at metal components. So the 2 systems that have been announced and are planning to come to market in the next 2 years, the one on the left side, which we'll talk about first, is the Studio system. This is the system that's actually launching this year. It was announced at Rapid in May. For those of you who were able to attend that, I'm sure you were able to see some of these systems in action there. I like to say that it was probably the only metal 3D printing company that had a system running at Rapid, so that's definitely one thing to talk about. Office environment safety is being able to run a metal 3D printer at a trade show. And the one on the right is their production system. So this is a system that is set to be released in late 2018, early 2019, and is more geared towards the production of metal components. So really they're trying to address 2 different areas here. One is the prototyping needs and short-run tooling needs of customers with the Studio system, and then also looking at what can we do on the production side to provide customers with a solution to 3D print larger volumes of metal components. So the first one we're going to go through is the Studio system. Again, this is the product that was released at Rapid. They're going to be actually shipping this system in September. CADimensions is going to have one of these systems towards August to September timeframe in our Syracuse office. So if you're around the area during then, please feel free to give us a call and stop in. We'll be able to show you everything that's involved with this technology. So the Studio system really involves several different components. So you have the actual printer, which you see sitting on that tabletop there, and then you also have a microwave furnace, so a furnace that's going to be used in the sintering process. And these are sold as a complete solution, which is something that a lot of 3D printing companies don't do, is they don't offer a complete solution for a company to be able to make one purchase by having all the equipment that they're going to need to be able to print and get their parts through heat treatment. So if you look at the Studio system itself, you know, one of the major components here is, if you look at the left-hand side here, is it's 10 times cheaper than any current metal 3D printer out there when it comes to the DMLS-based process. So we look at the DM Studio system. For a complete solution, you're looking at a total investment of $120,000. If you look at above line here for a DMLS system, you're looking at almost $1 million. So we're quite a ways away from that kind of cost standpoint when we look at the overall acquisition cost for a system like this. And I think more importantly is the safety factor. This technology is not using lasers at all. So it has no hazardous powders. It does not require any respirators. It does not need any external ventilation. It does not have any third-party equipment that doesn't come from Desktop Metal. It does not need a dedicated, very trained operator. And it really doesn't require any special facilities. So it really overall is a great type of system that can fit right into a office or lab environment without having to make many adjustments at all. So to get a look at what the technology is, Desktop Metal's technology is really based off of the MIM technology, which is metal injection molding. So what we're doing is we're actually using metal injection molded powders as their base for printing. And the process they've come up with is bound metal deposition. And it's very, very, very similar to the FDM technology, which was started by Stratasys, and the fact that they're extruding out a plastic. So what we have is, if you think of a pixie stick, so we have powdered metal that's actually held into a very thin casing of plastic, and that is what we're heating up and we're extruding out onto the build platform. And in the picture on the right-hand side, you actually can see the footer there, and then you can see a white line. And really what that is that's the separator ceramic. So one of the interesting things about desktop metal, which we'll talk about, is their support removal and the ease of use of being able to remove supports by hand, which is really groundbreaking when you think about metal 3D printing, because before this it was all done with machining. So we're extruding out a powdered metal cased part, building it up layer by layer, very, very similar to the FDM process. The system itself, a very sleek-looking system, operates with two heads. You have a model head, and then you have your support or your separator head, where it's laying down that thin layer of ceramic spacer material, which is allowing us to be able to print and be able to remove those supports by hand. It's safe and widely used like the FDM process, as very similar design guidelines to the FDM, and overall has really no safety hazards as far as handling any powders. So it's not like you're getting big vats of metal powder that you have to be worried about. They come in sealed containers and actually are in a rod form. As far as build speed, very similar to an FDM system. We're looking at about 1 cubic inch per hour. And the overall build area is a 12 by 8 by 8. That is the build size of the chamber, but the actual largest part that you can build is going to be a 10 by 6 by 6. One of the things with the MIM process, if you're not familiar with it, is that the parts actually print out or are produced in an oversized by 20%. And when they go through the sintering process, they actually shrink down to their net shape. So the build platform, while it'll be a little bit larger, your actual largest part you can make is a little bit smaller, because you have to take in consideration that growing increase to that shrink factor that's going to happen later on during the sintering process. After the part is printed and it comes off the machine, the next step is a debinder solution. So that is very similar to a wash tank that, if any of you use a Stratasys FDM system, very, very similar to that, where we have an agitation bath and a chemical compound that's going to be going into that solution. And it's going to start to remove some of that debinder and some of that ceramic spacer in the part. The part's actually going to reside into that solution for a couple of hours, and then it's going to make its way into the furnace. So the furnace here, you can see, is the picture on the right. It's a hybrid, so it uses both conventional and microwave frequencies to be able to heat up the oven to a 400 degrees Celsius. It does use argon gas during this process, and those canisters are hosted in the bottom of the machine. And the furnace is going to run from anywhere from 16 to 24 hours based on the part and material and volumes that you're printing in, which is all calculated in the software. One of the neat things about this process is all of these systems, from software to printer to furnace, all communicate with each other via the cloud. So they're sharing information and being able to know what exactly material you're printing out of, and being able to translate that information to the furnace so it knows how long it needs to run during the sintering process and what temperatures it needs to run at. After it is out of the furnace, you obviously have a completely sintered part. So we go from a brown part to a green part to a fully metal part. And if you're familiar with current metal 3D printing, the supports are typically removed by machining. So you can see here on the left-hand side, the support would have to be machined off using traditional CNC machinings. Right here, we're going to play a quick video that's going to show you how easy it is to remove the desktop metal supports. So you can see here, as he starts to pop out those supports with that small screwdriver, that powder, that's the ceramic separator that has been burned away during the sintering process. So it really allows you to be able to remove these supports very easily by hand in a very quick manner, which is not something that's been able to be done with any other type of metal 3D printer. So when we look at usability and ease of use, support removal is a very big concern with talking about metal 3D printing, and Desktop Metal on their Studio system has come up with a fantastic solution to that. So once the parts are done, it produces a near net shape part. Again, we're talking about in the MIM process, where we're going to have a 20% shrink that's going to close those parts down to be the actual size. And that growth or that expansion of that part is done in the software that you're processing these files in. So the files are the software does take native CAD files, so there's no need for an STL file anymore. So you're able to take your SolidWorks, your Pro-E, or your Inventor files and being able to put that right into the software, and it's going to make those adjustments as needed to be able to take that shrink factor into account. As far as resolution and accuracy, you're going to have very similar resolution and accuracy to that of an FDM printer. We're looking at about 2 thou plus or minus as far as accuracy on these systems. The densities are similar to metal injection molded parts, so they're actually not going to be solid. They're going to be some sort of porosity or sparseness to the interior of the part, and that is to allow both the heat and the binder spacers to be eliminated from the material itself. And the parts are going to perform similar to wrought alloys. So if you look up different types of MIM or MIM metals, you're going to be able to see that you can get those types of characteristics, and that is what you're going to be able to see off of this type of machine. So again, to kind of recap on the overview of the process, the one nice thing is end-to-end system software controlled workflow. So we're starting in a proprietary software that is from Desktop Metal. It's all cloud-based. It's going to communicate to your printer, which is also going to communicate to your furnace, which is going to automatically know how long it needs to heat up and keep for. So you're going to set up, you're going to print, and tool paths and everything are all automatically generated, very, very similar to an FDM, so there's not any tool path setup that you have to do. It's then going to go into the binder solution for a couple hours, and then it's going to go in the sintering furnace for 16 to 24 hours, depending on the thickness and the material itself. So overall, from start to finish, you're probably looking from 1.5 to 2 days from when you print a part to when you're going to have a part in hand. So the materials, as I said, there are basing their technology off of MIM, so they're using MIM powders. And there's really a big advantage to MIM powders. And really what's different to our materials, if you compare them to the current materials used in DMLS processes, ours are 80% cheaper. And it seems weird, right? They're both powdered metals, but what's the main difference here? Well, the main difference is their makeup. So laser powder bed fusion metal powder needs to be a very specific, high quality, uniform looking powder to be able to be sintered properly. With the metal injection molding process, it does not matter the uniformity of those materials, so we actually can use different types of metal powders that are going to be less expensive than you would if you're using a laser bed fusion system. So that is a real big advantage when you're looking at a cost of ownership for a company, to be able to know that the materials you're buying from Desktop Metal are going to be 80% cheaper than if you're buying them for a laser bed fusion type system. To look at the materials that are currently available, there are actually over 200 different types of MIM powdered metal materials. These 6 right now are the ones that are currently available on Desktop Metal machines. They are working to grow that number to be upwards of about 30, but really they're looking at now and looking at areas where customers are going to be demanding the most for those types of metals to be developed. So right now you can see that we have a 316L stainless steel. We have a 4140 low alloy steel. We have a 17-4 pH stainless steel. We have a copper. We have a Kovar F15, and then we also have a tool steel. And since this, they actually have developed a Inconel material that they're also able. So there's currently 7 materials that they're offering on these systems. So again, you can see the way the material comes in its shape. Again, when I talk about a pixie stick, it does kind of look like a pixie stick in the fact that that is very compressed metal powdered material that's put into a very thin casing of plastic, and then it's put into the machine via these canisters. So when you're changing out materials, you're just changing out the head and you're changing out the canister. So for those of you who run FDM systems, maybe a Fortis, it's very similar to doing a material change over there, where you're taking out a cartridge, you're changing out a tip, and you're putting in a new cartridge and you're putting in a new tip. So the process is very easy, very clean, and very office friendly. So that is currently the studio system. Again, CADimensions is going to be having one of those systems, and we're hoping in August and September. It will reside in our Syracuse headquarters. So for those of you who are local to Syracuse, or for those of you who wish to be able to see that system, please let us know. We'll be happy to have you in. We are planning an open house once that system arrives to invite all of our customers to check it out. So the next system we want to talk about is the production system. So this is a system that is set to be released later in 2018 to 2019. And this is really a different type of metal 3D printer. This is a larger scale 3D printer. As you can see here in this rendering, it's a very large system with several furnaces involved in it. And this technology is being powered by single pass jetting. So really what they did here is they took a combination of binder jetting and inkjet processes to create this type of workflow. So this system right here is a 13 by 13 by 13 build volume. So it is printing in an entire bed of powdered metal. So similar to what you think about a powdered metal of on a DMLS machine, but this one is a powdered metal of MIM powder. So again, you're still continuing to get those cost savings with the reduction in the metal powder cost. And what this machine is doing is it's all about speed. So this machine is going to be 100 times faster than any other laser-based system out there. So what we've learned is that this can build its whole build volume within 6 hours during the build process. So a 13 by 13 by 13 inch build volume can be built in 6 hours. So really what they're looking for is this is going to be used as a production system. You know, for customers out there who are looking for a replacement for maybe casting that want to do low to mid-volume production parts, this is going to be a great opportunity for them to get involved. Again, the 20%, 20 times lower cost, and that is, again, going to be based on the ability to use that MIM powder. And if you look at competitive cost per part, you can see up per part for the laser bed fusion, and you can see where the desktop metal production, and you actually can see at what point at about 100,000 parts is when we would be matched up with the cost comparison for traditional castings. So any company that is looking to produce high volume parts of maybe 1 to 100,000 components in a year, this can be a great answer for you when you're looking at a new solution to be able to manufacture those products. So a quick summary of some of the things that we covered. So Desktop Metal Studio system is going to really provide manufacturing world with the first affordable system. So everything you're going to need with this Desktop Studio system is going to be for $120,000. That is really groundbreaking when you look at the overall cost of traditional metal machines, and it's going to open up the door for a lot of companies who've had the desire to be able to get into metal prototyping to be able to start have access to this type of equipment. It's office friendly, so you're not going to need any specialized facilities to be able to run this equipment. It's going to fit right into any type of lab or manufacturing environment that you currently have. And it's a very easy to use end-to-end solution. So when you're talking about an FDM style printer, for those of you who have been using them, you know how easy they are to run. You're going to have a very, very similar experience with running this type of studio system. So some frequently asked questions that we do get. So how much does the studio system cost? Again, a full-length solution is going to be $120,000. And what that gets you is that gets you the studio system, that gets you the microwave enhanced furnace, and that also gets you the debinder station. So everything that you're going to need as far as equipment to run a desktop metal system would be in for $120,000. And we also have another program where you can pay $3,900 a month with options to buy out the system at the end of it. When our system's scheduled to ship, the studio systems are scheduled to ship to the general public in September. So they are taking orders now and taking reservations. Obviously, it is a first-come, first-served basis. So if you are interested in it, please let us know. We'll be happy to talk to you more in detail about what you're looking for. And the production system will ship to pioneers or first customers in mid-2018, and then will be available to the commercial world in 2019. What materials are available? So again, like I said, there are 6 materials currently available. We have 316 stainless steel. We have 4140 low alloy steel. We have a stainless steel with 17-4 pH. We have a copper, a Kovar F15, and then we have an H13 tool steel. And this is just the starting point for desktop metal. With 100 engineers and many PhDs and many metallurgists, they're out there trying to develop and work on more and more metals that a lot of customers are going to be able to use and fit into their current prototyping process. And can you schedule a demo? Absolutely. As soon as CADimensions has its system on site, we'd be happy to have any customers who are interested in coming and visiting us and taking a look at the system As soon as we have our system, we'll be sure to be blogging and letting everyone know about it. If you want to see a system sooner than that, Boston is not that far away, so we certainly can schedule some time for you to be able to go out and then see Desktop Metal and see its office and see everything in action. We do have some upcoming events. So for those in the Buffalo area or near Buffalo, we'll be at one of our customer sites, Buffalo Manufacturing Works, on July 11th with a Desktop Metal machine, and a gentleman from Desktop Metal will be joining us. We have a couple time slots that are available. We do have a limited space available for each of these time slots. So if you are interested in making the trip to Buffalo or live in the Buffalo region and want to stop in, please be sure to reach out to us and we can let you know what availability we have at these time slots. And then, like I said before, we do have a planned open house in Syracuse. We're planning this for September to give us some time to get the machine in and up and running and be able to allow all of our customers to come in and check it out. And then after September, we'll be planning to look at bringing this system on some type of roadshow, hopefully in Q4 or Q1 of next year. So with that, if anyone has any type of questions, please feel free to put them in the question box, and we'll do our best to answer them at this time. Here is my information. If you do want more information on Desktop Metal, you can contact me here in our Syracuse office or my email, or you feel free to visit our website. We have a dedicated page to Desktop Metal, so you can get all of your information that you're looking for. So we have one question here, and when is aluminum scheduled to be available? Aluminum is actually their next, from what we've been told, the next metal that they are working on right now. We do not know an exact date of when it will be available, but that would be one of the next materials that they are planning to release right now. So it is something that has come up in conversation quite a few times. Obviously, it's a very popular metal out there, so they are working diligently to be able to bring that to market. Hopefully, we'll have some more clear answers as we head into the fall timeframe, but yes, they do have aluminum at the top of the list for development. So we have a question here is, how do you dispose of the support material? The support material actually is burned off, so the support structure that is holding this part is actually the metal itself, and what it is separating it is that ceramic spacer material. So that burns away, and then you'd be left with the metal placeholder, and then you'd be left with the metal component. We have one other question here. Are material properties isotropic? I do not know the answer to that one, but we'll certainly write that down and look to get an answer back to you. Now they're rolling in here. What is the resolution of the printer? So as far as layer heights, there are several different layer thicknesses that this machine prints in, but the default one is going to be 100 microns. And the accuracy of X and Y is going to be 2 thou. Will you be able to hollow infill-like structures similar to that of FDM plastic printers? Yes, actually all the components are going to be having some sort of hollow structure on the inside of them. And again, that is going to be due to the binder and the part having to release of the heat. You're actually not able to print a completely solid part. All of it needs to be somewhat sparsed out in the side. Obviously, if it's a thin blade type component, that would be solid, but where it can, it's going to have some honeycomb into the interior of it. So very similar to what you see on the FDM printers. So the furnace is going to be a three-phase, I believe it is a three-phase 220. So very similar to what runs a Fortis system, and that is going to be what is going to be needed to run the furnace. You can ventilate the furnace for heat purposes. Can materials be plated? Yes, materials can be plated. These materials can be machined. They can be sanded to be finished. They can be welded together for bonding. So, depending on what you're looking for tolerances, they've talked about customers who want a very nice looking part being able to sand the part before it actually goes into the furnace. So you have a softer part that you're able to sand away much faster than if you're trying to sand or machine away a full metal component. But again, With your hand sanding, you'll be losing any accuracy that may be done with the machine, but if it's just a showpiece that maybe you don't care about the accuracy so much, it's a good option to be able to get a nice surface before it actually goes into the sintering process. So we have another question here is, what are the minimum and maximum wall thicknesses? So that is actually a good question. We do have a minimum wall thickness, and we do have a maximum wall thickness that you need to take in consideration. So it is interesting, because you would think with the FDM process as we know it, you typically only think of a minimum wall thickness, but with this process, you actually have to think of a maximum wall thickness. A maximum wall thickness is actually going to be 8 millimeters. So that is the maximum solid part it's going to be able to print. So the center of the parts are going to be honeycombed. The shell of that part is going to be that maximum wall thickness. So there is a thickness that they need to keep the parts. So that maximum wall thickness would be the most allowable shell. Can you use this for injection molding? That is a very good question, and it's something that they are working on right now to testing out. You would need to do some sort of polishing to the exterior of the part, so the part's going to kind of come off the machine and look very, very similar to an FDM component. So you're going to have those layer lines, so it would require maybe some sanding or some machining to be able to get a nice smooth surface. But they are looking at testing this application, and we hope to have some more information on that application later this year. But it does look like a very good opportunity for companies who are looking to use maybe some metal 3D printing to make molds. One last question here. You can machine the part. Do you machine it as a cast steel or as a solid base material? That is a very good question. That is one I'll have to get back to you on. One other question here, can parts be heat treated? Yes, they can be. So if you are looking to increase the quality of the metal parts themselves, they can be heat treated. All right, it looks like we've wrapped up. If there's any questions I didn't get to, I will go back through these, and I'll make sure that we reach out to you with some answers this afternoon. I appreciate everyone taking the time to join us today. And if you have any other questions, feel free to give us a call or reach out to your local CADimensions representative, and we'll make sure we get your answers. So again, thank you for joining us, and please have a good rest of your day and have a safe and happy 4th of July weekend.
Don't forget to check us out on YouTube, Twitter, Facebook, and our blog for more great content by clicking on the links in the description below.